Greetings, Earthlings. Well, it's time to take another look at this HP multimeter. See if we can get it repaired. I've got some PNP transistors. These are 2N4037s. I also have the manual for the meter section, or the meter as opposed to the display section, right? But the problem we have initially is in the power supply of the display. And if you haven't bothered to watch the previous video, or if you're just stumbling across this channel, stumbling, it looked like that transistor there was bad, and that is a 2N4037. So replacing it is going to be a problem because it's behind here. So there's a couple of screws like that one, and well, maybe that one, and what is it, that one over there? Yeah, that I'll have to take off to remove the transformer to get at that. But before we do that, we're going to take a look. I've got one of the I've got my curve tracer here. Now I want to eventually get a more permanent setup for this, and I have a couple of options for the display. This won't be the permanent, because I want it to be in a basically permanent spot, easily set up, so I don't have to drag it down here to the bench and set it all up. And I won't be using that as the display. I have a couple of options for the potential display, but we'll get to that in some other videos. Okay, so here's a potential replacement resistor, transistor. It's one of these. This one says GE/RCA on it. Okay, these apparently came from New Jersey Semiconductor, and some of them say GE, but most of them seem to say GE/RCA. Well, maybe they all say that. I thought I saw one that just said GE or just said RCA. Doesn't matter. Well, it might matter to GC or RCA because, you know, is that a trademark violation? I don't know. Anyway, just want to verify that this transistor looks like a transistor, and so there it is. It's a PNP, so it's the curves are coming down this way, and that looks like that's at 20 volts. It operates. Well, let's see. This is on the minus 12 volt supply, I think. So coming in might be, maybe 20 volts, maybe 30 volts. Let's just make sure that, let's go up to 30. Make sure, yeah. So it can handle that. We'd see these turning that way if we get the voltage too high. And that's getting up to, that's 40 volts. And it's still fairly linear, which is good. Okay, I'm not gonna try and blow it up. I hope you don't mind that I don't try to blow it. That's 10 microamps per step. I can change the stepping, and you'll see that it just it's fine. It's happy. It's plenty happy. In any case, next step is to pull out that transistor, and we'll look at it on the curve tracer as well, and I think what we see will be something very different than what we saw from this transistor. Okay, and that was harder than it should have been. It doesn't come apart very easily. I was not able to get a solder sucking tool on it. I had to use braid to desolder it. But there is the part, you see. It's still, and it's still got the heat sink on it. And so this is what it looks like. And Well, that still looks like a transistor, but let's compare that. See, it comes down to there. And that's what this set to 20. Well, it doesn't really matter, right? Compare that with this one, the new one, which I would say I think the new one's going in regardless of whether this test's okay or not, just because of how hard it was to get it out and because I don't trust it. But okay, so that's a significant difference going from there to there. Different. Does that explain the behavior we were seeing? I'm not sure. I'm just not sure. But like I said, I'm going to replace that anyway, and we'll go back and test it and see what we get. All right, further investigation finds this diode here to be bad, CR26. And here it is. And you can see that's like an open circuit in that direction. And if I switch polarity, I'll wait for that to come back. It's open circuit in that direction as well. So, what is that diode? It's an FDG 1088. What? Never heard of it. Never heard of it. 30 milliamp, 30 working volts. I think a... let's burn a hole in the screen. I think a 1N4148 will probably be an acceptable substitute. The only thing about this one is, like, it's painted, maybe to keep the light out. I don't know, or I don't know. That's a mil-spec part. I don't know. So the transistor may have been good after all, as we saw. It was acting different than the new ones, but possibly still good. So let me put a new diode in and see what happens. All right, and with that new diode in place, what we can see is, checking again the Zener, 0 volts on that side because it's grounded, and whoops, 13.3-ish. Okay, that's much, much, much better than what we were seeing before. Can't measure the plus or minus 12 without having this plugged onto that, because it goes through the connector, which we'll show you in a minute. But so there's the replaced diode. I left the other one because there's 2 in series. I left the other one as it is because it seemed reasonably happy. Okay, so let's bring this over now. Plug them together. Yeah. Okay. And let's see what happens. So now, here's ground. Oh, and look, the label fell off the transformer. I'll have to re-glue that. There's ground. And there's plus 12. I said there's plus 12. What? Do I have to turn it on? Maybe I have to, maybe I have to power it on for that to happen. Okay, there. Now, minus 12.4. Okay, I'll take that. 12.4. Okay. Well, okay, that, at least that power supply is fixed. Now, Figure out if it's even close to being in spec. Or let's see. Let's bring back the well. Let's bring back the 100 ohms, because remember that was actually almost showing like close to accurate, except it was bouncing around a lot. So let's just see. I did that too before. Okay. Switch to ohms. Oh, look at that. Wow. Wow. Okay. Oh no. And the plastic here on this binding post just fell off. I'll have to figure it out if I can glue that back together. But 100 ohms. That's 4-wire. Let's see. Overflow. This should be close to 0. That's pretty close to 0. Okay, what else have I got? I've got. Okay, 1433p. General radio. So that's 0 ohms. And it's saying 0.005. That's close enough. Okay, so that should be 10 ohms. And that should be 100 ohms. That's 1,000, 10,000, 100,000. Yeah, pretty close. 1, 2, 3, 4, 5. Okay. Yeah, it sure looks like that's in spec. Okay, so it looks like the power supply was really the only problem. So we can check voltage. We can check voltage. Here we go. It's on volts, yeah. Okay. This is from the Fluke 343A. It's currently set to 0. Let's give it 1 volt. This thing might not even need to be calibrated. 2 volts. 3, 4, 5, 10 volts. Oh, I want to tweak it a little bit. I would like to see it a little closer than that. Okay, let's go to the 100 volt range here. 10 volts there, and bring it up to 100 volts. Still pretty close. Needs a little tweak. And this can take 1,000 volts. It's got 1,000 volt. Oh wait, let's see. You know, if I were calibrating it, I would go 100 and. No, I would go 190. Well, I can't go 190. Oh, not on that range. Okay. I would go 19. Right. 19. Just sort of high end of the range. Okay. Anyway. Let's go to the 1,000 volt scale. 100. 200. 300. 4. 5, 6, 7, 8. It's showing overload. Uh-oh. Oh no, did I blow it up? It's now at 0. Did I blow something up? All right. Well, I found two problems. One of which I think is unrelated to what we're seeing, and one of which I think is the problem. So, there's two fuses in here. You see this? Yeah. There's one fuse here, and there's one fuse here. Okay, this fuse was bad. It was blown. That's a 1 amp, 125 volt 1 amp fuse. I think that's to protect it from overcurrent on the current range. So I never tried measuring current, but that probably, I probably wouldn't have been able to, and that's probably the reason. But that's not what is causing the what we're seeing right now. There are some diodes here. This is on the input protection circuit, okay? And these are funny, very low leakage diodes in a, whatever that is, TO18 case. And this one is not acting like a diode. So, probably, you know, when I hit it with whatever it was, 800 volts or something, that gave out. It should be able to take 800 volts, but maybe it had been previously stressed. I did notice, and I don't know if I pointed this out before when we first looked at this, you can see down here that this part has been replaced. There's this flux there. So whatever that part is, 1826-0111 has been replaced at some point in the past for whatever reason. So anyway, that's interesting. Now, in terms of replacing this diode, you know, the spec on it is 30 working volts, but 10 picoamps leakage. 10 picoamps. And that's less than your typical, you know, diode, which is why it's a funny package and stuff. I can find a replacement. Yeah, there are replacements. It's part number is pad 1 through pad 10, where the numbers, pad 1, 2, 5, and 10, where the number there is the leakage current in picoamps. So anything from a pad 10 on down would be fine. Pad 2s seem to be readily available, but they're like $15 a piece. Another possibility, people tend to use the base collector junction of a bipolar transistor like a 2N3904, and I don't know, you know, what we would see with that leakage wise. It's supposedly pretty good, you know, or I could ignore all that and just stick a 4148 in there and hope that's good enough. But I guess I'll have to figure that out, and we'll take it from there in the next video.